как? Да? Okay, so first of all, a small comment about homework. I sent a solution, but just one more comment that it seems that yes, several people didn't understand correctly how our complex is defined. So I just would like to emphasize that our group of cochains with respect to an open covering U is defined as the product I0, IQ, F, U, I0, so in particular, in the second problem, so when we considered a circle covered by two open sets, so C1 U Z is Z of U1 U1 plus Z U2 U2 plus Z U1 U2 plus Z U2 U1. So, and this is equal to, as you see, Z to the power 6. So, yeah, so several people wrote that this is Z to the power 2 or Z to the power 4. So, but okay, this is our definition. Actually, there is a related thing that I would like to mention, because it may be that probably some people maybe read some other books, and I would like to tell you that there are two main ways to define this cohomology, because there is other way using skew-symmetric cochains. I mean, okay, remark, strictly speaking, it will be not used later, but it is good to know that. So another definition approach to cohomology one can define skew-symmetric cochains. One can say that some cochain is skew-symmetric if f I0 IQ is equal to 0, if IK is equal to IL for some k not equal to L, and if you permute these indices, then and the sign changes according to the sign of the permutation. So f I0 IQ is equal to the -1 sine sigma f I sigma 0 I sigma q. Yeah, where sigma is a permutation from the set q to itself. Yes, and then one can, for example, denote by CQ, I don't know, bar, Q this subgroup of skew symmetric cochains. Yes, and then we can define cohomology using the complex of skew-symmetric cochains. Using yes, and then there is a non-trivial fact that this definition gives the same answer. So non-trivial fact that this gives the same answer. Yeah, so one can define cohomology using skew-symmetric cochains or using our approach, and the answer is the same. But it's not trivial at all. Yeah. So yeah, in particular, yeah, if you consider skew-symmetric cochains, then indeed, yeah, for example, yeah, if you consider skew-symmetric cochains, then in our example here, of course, C bar 1 U Z is of course Z2. Yes. Okay. But again, we will not use this fact in our course. Any are there any questions? Sorry? Yeah, it's actually it's not trivial. Not trivial. Yeah, I will probably give a reference in the lecture notes. Where one can read it if one is interested. Окей. Она поставлена здесь для того, чтобы она падает, что ли, или что? Okay, so we continue. Yeah, first of all, yeah, there's a simple lemma. We already mentioned that. It says that if X is a topological space, have sheaf of abelian groups, then the zero cohomology group is isomorphic to the group of sections of our sheaf over X. Yeah, this is yeah, very simple. Yeah, we already. Yeah, this just follows from the fact that we already saw that there is a map from Fx to the cohomology with respect to an open covering. So open covering. Yeah, we denote it by mu u, and it's an isomorphism. So actually, yeah, the cohomology with respect to any open covering is isomorphic to Fx. And okay, if we have a finer covering, so we will have if this is a finer, this is a finer covering. Then okay, we have mu beta, and everything commutes. I mean, and this is isomorphism. We have this restriction, which we denoted by, and this is also an isomorphism. Yeah, and this commutes. I mean, so this diagram commutes. Okay, so okay, and then from this it follows that yeah, then according to, I mean, then okay, one has to probably think about how we define this this thing. But then, I mean, from the fact that all the maps are isomorphisms, it is clear that this is isomorphic to this. Yeah, so I don't want to spend too much time on that. Okay. Okay, then we need the following already more interesting result. It says the following. So consider a smooth manifold. Okay, with countable topology. We need this countable topology for some technical fact. With countable topology. Yes, then. В смысле, как дальше доказывается? Ну да, да. Ну, понимаете, здесь как бы все отображения как бы изоморфизмы, да, то есть... ну да, то есть, конечно... ну да, то есть у нас... ну да, то есть есть, строго говоря, это определено как там множество классов эквивалентности. Вот. Ну просто дальше у нас есть же отображение... Ну как вот... okay, so here, strictly speaking, we have the map from H0, any open covering. Где? А где фигурная, где прямая? Что? Да-да, я извиняюсь, да, это... Нет, разницы нет никакой. Yeah, of course, we have a map from H0 to HXF. But then you just check that it's an isomorphism using these facts. Okay, we have this map. I mean, that assigns to cohomology class here. Its equivalence class. Then I claim that it's an isomorphism. But okay, I mean, you just... okay, so we should prove that it's surjective and that it's injective. Okay, you want to prove that it's surjective. So you consider any element here. It is represented by a cohomology class with respect to some covering. Then you look for a covering that is finer than both this and that one. And then, I mean, all the maps between them are isomorphisms, so you find, yeah. And then, okay, in the same way you prove the yeah. So, I mean, you just should think about the definition and see that, I mean, since everything here, all the maps are isomorphisms, so nothing bad can happen. Okay, yes, and then I claim that then HQ X epsilon is equal to 0 for any positive q. So, and I recall that by this epsilon we denote the sheaf of smooth functions. Sheaf of smooth c-valued functions. Yes. Okay. This is based on the following fact that you studied, in the course about smooth manifolds. So there's a notion of partition of unity. Okay, and I recall it. Okay, so for any, so recall that for any open covering U of our manifold of X, there exists a partition of unity subordinate to this open covering. There exists a partition of unity subordinate to U. To U. Yeah, what does it mean? What is a partition of unity subordinate to U? So this is a collection of smooth functions. So it's a family GI of smooth functions of functions. So GI goes from X to R, satisfying the following properties. Satisfying. So so the first property is that GI is between 0 and 1 for any I. Then the support of GI is inside UI. Yeah, when this, I recall that this support means the set of points in X such that GI is not equal to 0, the closure, and you take the closure. GI of X. So the support of the function is the closure of the set of points where it is non-zero. And yes, the family of supports is locally finite. So the family of supports is locally finite. yeah, and it means that that every point x in x has an open neighborhood that intersects only with a finite number of supports. That every point x has a neighborhood v such that v only for only finitely many yes, and then yeah, the sum of the sum of these functions is equal to 1. Yes. So yeah, and then okay, the third property guarantees that this sum is well defined. Yeah, for any point x, there is only finitely many gi's that are non-zero at this point. So this sum is well defined. Okay. Yeah. This is a standard fact from the from a basic course of analysis on manifolds. So it's assumed that you studied that. Any questions? Okay. Okay, and then yeah, then we can use we use this partition of unity. So yeah, it is sufficient to prove that sufficient to prove that HQ of any open covering is 0 for any open covering. Yes. Okay. So we take and we just explicitly construct. So for any co-cycle, we explicitly prove that it's a co-boundary. So we take f a co-cycle and then okay, okay, and then okay, we have this partition of unity. Okay, all right. Take a partition of unity gi subordinate associated to this open covering. Okay, and then consider some indices I0, IQ minus 1, J in I. Okay, and then we yes, then okay, we have this function psi I0 IQ minus 1 J ну, я еще не закончил доказательство, да, то есть, да, все нормально. Да, ну, я же, сейчас будет конструкция, да, то есть все, ну, как бы все будет хорошо. Значит, okay, so these elements are smooth functions on ui0 yes. Yeah, and then we can, of course, multiply this by gj. And it's also it remains a smooth function. But then this function, because, yeah, what is the picture? This uj, and if we consider this uj, or maybe just let us write one-dimensional picture here. So we have uj, and then our function support. Yeah, so support is of j is inside uj. So it looks like this. So actually, this function can be extended to this intersection. So this actually can be extended to a smooth function on u I0 u iq minus 1 by assigning 0, by saying that it is 0 outside outside this intersection. So you say that by assigning it value 0, on the complement. So on u I0 u iq minus 1 without u I0 yes. So so we consider, so we will write that this j is actually a smooth function on ui0 uiq minus 1. Yes, and then we define a q minus 1 cochain h iq minus 1 by minus 1 bar q sum overall j in this set I, g j f I0 I yeah, as the sum. So this is a smooth function on U. Yes, and then we just directly check that delta of this thing is f. So then we compute the delta h I0 IQ okay, just by definition sum k is equal to q minus 1 to the power k h I0 q minus 1 yes, we now write the definition for this thing I g f I0 k q j yes okay yes, then we just change summation. So we write sum I swan to power q g j sum q g f I q j yes, but then here we recognize here we recognize delta f delta f I ij I q j minus the last one minus f I0 IQ IQ missing j. Да, конечно, да. Yes. Yes. So this is 0. So we have this one, and then the sign minus q, minus 1 to the power q. So we get sum I gj f I0 IQ. Yeah, but then sum of this is partition of unity, so this is 1. So we get Okay. Yeah, so delta H is equal to F. So F is a, so the cohomology is 0. Are there any questions? Okay. Ну, здесь же, ну, чтобы предыдущий построить, как границу представить, как бы. Okay. Yes, then the next useful effect that is a corollary of this one, which I already and I already mentioned it. It says that another theorem. Yeah, we will have several statements about all cohomology groups, but after some point we will focus on the first cohomology group. So in particular, yeah, this is about this theorem as well. About the first cohomology group. So suppose that X connected, smooth, connected, simply connected, connected, smooth, smooth manifold with countable topology. Then, yeah, the first statement is that H1 of X, the sheaf of locally constant functions with values in C, is equal to 0, and that H1 of X Z is equal to 0. We already used that. We already, I already mentioned this fact. Okay, let us prove it. Ну да, то же, ну, здесь же любое, да, то есть любая. Да. Да, обычно там, да, эти все переход другим коэффициентом, да, получается с помощью точной последовательности. Да, мне кажется, должно быть тоже 0. Вот. Но так я, наверное, не готов все-таки гарантировать стопроцентно. Okay, so the proof is the following. Yeah, again, we take any. So let us prove. So let us prove that each one with respect to any open covering is 0. So we take again some cocycle ij in z1 of u c. Yes, then. Yeah, of course. I mean, this is the group of cocycles of the sheaf of locally constant functions, and this is of course a subgroup in the group of cocycles of the sheaf of smooth functions. Yes. So, but we already proved that this thing is equal to the group of coboundaries. So this co-cycle as an element here is a co-boundary, and it means that there exist functions fi ui such that Cij is equal to fj minus fi on ui on all intersections. Yeah, so you see, we want to prove that this is a co-boundary with respect to the sheaf locally constant function. So we want to prove that this can be represented as a difference of locally constant functions. But okay, according to the previous result, we can represent as a difference of smooth functions. Okay, then what we do? Yeah, then we take the differential. Yeah, but yes. So d. This Cij's are locally constant functions. So d Cij is equal to 0. So yeah, so it implies that dfi is equal to dfj on ui. So these one forms, they glue in a global one form on X. Yeah, so there exists omega, different smooth one form. We denoted the space of smooth one forms on X by this symbol. Yeah, such that omega restricted to ui is dfi. Yes, and then okay, but then clearly d omega, yeah, obviously, so d omega, the differential of omega is equal to 0. Yeah, yeah, because I mean, if we restricted d omega on ui, then d omega then if you restrict to ui, then omega is dfi. Yeah, but then d of d is equal to 0. Yeah, so okay, this thing is equal to 0. But then and here we use that this is a simply connected manifold, and we know that if a manifold is simply connected, then any closed form is exact. Yeah. So X is simply connected. We know that omega is df. That omega is df for some smooth function f on X. Yes, and then we define define Ci as Fi minus F restricted to Ui. So this is a priori it's a smooth function on Ui. Yeah, but then dci is equal to dfi minus df but then dfi is omega, yeah, so this is omega, yeah, and df is also omega, yeah, so this is 0. So it means that Ci is locally constant, yeah? That Ci actually belongs to the sheaf of locally so it's locally constant function. So ну, а мы же это да, так определили f. Okay, and then yeah, and then we have that Cij is equal to Fj minus Fi, but then we can write it, this is equal to Fj minus F minus Fi minus F. So this is, yeah, so this is equal to Cj minus Ci. Yeah, so it implies that, yeah, this co-cycle is a co-boundary. Are there any questions about it? So it was the first part. Now the second part. So what we do. So now we would like to prove that this group is 0 with respect to the, if we take the sheaf of locally constant z-valued functions. So let us prove that each one of u z, and then we take so we take Aij, a one co-cycle, then by the first part, by part 1, there exist CIs, C U UI, such that Aij is equal to Cj minus Ci on UI. Yeah, and again we want to prove that we can, these are complex locally constant functions, but we would like to prove that we can choose z-valued locally constant functions. Yeah. So yeah. So this is an integer. So we have that exponent 2 pi I aij is equal to 1. So it implies that the exponent of 2 pi I Cj is equal to the exponent 2 pi I Ci on this intersection. Yeah. Then since x, so ну это же целое число, и ij это целое число. Okay, so x is connected. So it implies that there exists some constant such that b is equal to the exponent 2 pi I C j for every for every j. Yeah, so since we have this equality, then this function exp, so then actually all these functions, so these functions, they glue in one function on the whole x, which is locally constant. And so since x is connected, so this locally constant function is constant. So there exists this constant, and then we just choose some c such that exponent 2 pi I c is equal to b. Yes, and then we let ai be ci minus c. But then okay, a priori it's again it's some function, a c-valued locally constant function. But then if we choose exponent of 2 pi I ai is equal to exponent 2 pi I ci exponent minus 2 pi I c. But this is equal to 1. So this is equal to 1. So ai is a z-valued locally constant function. Yes, and then yes, and then our co-cycle aij is equal to cj minus ci, but then it's obviously equal to aj minus AI. So it implies that this co-cycle is a co-boundary. Yes. Ну как, ну мы везде пользовались, то есть мы же, ну как, ну сначала мы пользовались, что это, ну, ну да, ну да, да. Okay, so if... Что за тема в Анкаре? Да-да, да. Да-да, односвязность, используется односвязность, да. Ну да, да. Ну да, то есть да, в итоге-то как мы же доказываем, что К-цикл является кограницей, да, то есть мы представляем его, вот мы строим ее вот здесь вот, да, CI, CI это FI минус F, да. Дальше мы заключаем, что это локально постоянная функция из того, что дифференциал равен нулю. Вот, ну, как бы. Ну, видите, а дальше, чтобы доказать, что это можно до Z довести, это, ну, как бы немножко дальше нужно рассуждение провести. Okay. Okay, then we continue. With properties of the first cohomology group. There is the following lemma. Hopefully, probably today and a bit part of the lecture next time will be devoted to some general facts in sheaf theory, but yeah, in the next lecture we will start again with holomorphic, with Riemann surfaces. Okay. There is this lemma. So X is a topological space. The most general situation, F of sheaf of abelian groups. And we have open coverings, an open covering and a finer covering. Open coverings. Then we have this map. Then the homomorphism. This restriction homomorphism from H1 U F to H1 is injective. Is injective. Yeah, a priori we didn't know anything about it, but actually it is injective. Okay, the proof is the following. We have to go to the details how we constructed this map. So this map is constructed using a refining map. So we choose a refining map. phi. Yeah, so B, we should fix some notations. So B, so U is the family of open sets UI indexed by I, and B is the family of VJs indexed by J. So we should fix a refining map from J to I. Yeah, so it means that that Vj is included in U phi j. Yes. Okay, so what we should choose some alpha in H1 U F, and suppose T U P alpha is equal to 0. So we should prove that alpha is equal to 0. So let us prove that alpha is equal to 0. So we choose a representative for alpha. So Fij in Z1 U, representative of alpha. Representative of alpha. Yes. Then just recall the restriction homomorphism. Then phi, we have the induced co-cycle with respect to the open covering B. So phi ij is defined as f maybe kl, f phi of k, phi of l restricted to vk el. Yeah, so this represents TU, the restricted class. And then, okay, since this guy is 0, then we see, yeah, so that this belongs to the group of coboundaries. So yeah, so we can represent it as delta of some zero cochain with respect to the covering B. So there exists a cochain J such that yeah, so this element is that, yeah, phi is delta G, but then it means that f, this guy is defined in this way, phi k phi L is equal to GL minus GK on VK VL. Yes. Okay, so we should remember this equation. Yeah, then we choose one more index, I. Yes, and then we write just again explicitly the condition delta f equals to 0 implies that 0 delta f phi k phi L I is equal to f phi L I minus f phi k I plus f on the intersection u phi k phi L intersected yeah, so we have this equality, yes, and then we and then yeah, this intersection contains VK VL UI. So we can further restrict to yeah. So we just restrict this equation to this intersection VK VL UI. So f VL I minus f VK I plus f VK VL is equal to 0 on VK VL UI. But then, since this guy is inside VK intersected VL, we can apply this equation. So we can express f pk pl in this way. So we write f pl I minus f pk I plus gl minus gk, yeah, again on vk and we can rewrite it as yeah, so v f pl I plus GL is equal to F Vk I plus Gk on Vk yes. And then one can use it to construct some co-chain with respect to the covering U, because what one can now do, one can write, so let V tilde Li be the intersection of V L and UI. Yes. And G tilde L I is equal to GL plus F VLI over restricted to VL UI. It's an element, it's a section over V tilde Li. Yeah, and then you see that I mean this condition, this one, it says that these sections, they glue together in some section of F over UI. Why? Because V V tilde Li L in J is an open covering of UI. And this equation, it implies that that this G tilde Ki restricted to V tilde Ki V tilde Li is equal to G tilde Li restricted to V tilde yeah, so we use chief axiom 2, so there exists how I denote it. So there exists Hi in F UI such that Hi restricted to V tilde Li is equal to G tilde Li. Yeah, so which is the same as Hi is equal to GL plus F VL I on VL yes. Okay, so we have several minutes, but it's I think it's enough. Yeah, so again we again write some again, write again this condition that delta f is equal to 0. Delta f ij ij phi k is equal to 0. It is the same as f g j f k minus f I f k plus f I j equals 0 on ui uj ufk ufk, but we would like to restrict it to vk, so actually okay, so I write in this way and then restrict further to vk. Yeah, so we have this, yes, yeah, so then we write this again, we on this intersection on ui uj vk. What we have, we write this fij, we just rewrite this equation I fk minus f j fk. But then we can use this this equation, yeah, this one. Yes. Yeah, so we should yeah, so then we write f, we should use the skew symmetry, yeah. In the homework we had this property that if we interchange two indices, then it changes the sign, yeah. So then this guy is minus this, and minus this is equal to gk, yeah, gk minus hi minus gk minus hj is equal to hj minus hi. Yes, so you see f ij, and this is true on ui uj vk for any k in j, yeah? So but again, we use chief axioms here. These intersections, they cover this ui intersect with uj. So we see that this equality is true on ui intersect with uj. So hj minus hi is equal to fij on ui but then it means that fij is a coboundary, belongs b1 u. Okay. So this is the end. Are there any questions? Okay, so if not, then we finish. Yeah, and then we will start a test in 5 minutes. Yes, 6 minutes. 6 minutes. А? Да-да, можно.